state this as I guess it's on the top of the hour, but the idea for this session is to discuss the various libraries that are in use and where there are gaps. And this might inform work that happens at a hackathon or elsewhere. It's an effort to just make sure as the RATS work expands out to other working groups that we know what tools are needed or what gaps we need to fill so that another working group doesn't begin down a path and falls short, right? Or doesn't have what they need. And so how do we close that gap? And we used to have somebody who would fill that gap very readily for us, and sadly, we don't anymore. So, Jim Shad would code and provide good code for so many efforts. So I thought that this might be a way to get the community to contribute.
Got it. Kathleen, you seem to be muted again.
Thank you. Sorry. I've been up since 5:30 in the morning, so I really should be fine at this point. But Ned, do you want to run the slides since you normally do that portion? I approved all of them already. I don't know if he's busy working or. All right, we have 3 presenters today. And because Michael won't be presenting. And I see I did not post, so I will share the agenda. We had Michael up first, so Thomas, would you be willing to go first? And he's going to present the Verasion. Yeah, I might be pronouncing that wrong. Stack that's mostly written in Golang and Rust. And we've given him about 15 minutes of time.
Should I go or?
Yes. Yeah. Do you want to, if you want to run your slides yourself, you can, or.
Oh, I don't have the slides at hand. Sorry.
Oh, okay. I think I figured out how to do it. I'm just used to Ned doing it for me. Okay. Can you see it?
Yes. Fantastic.
Great.
Thank you, Kathleen. So the goal here is to give you a brief introduction to the project, an idea of what Verasion is and what it provides, and basically how you could make use of it once you understand what it does, and in fact possibly contribute. This is something we're looking for. To your active involvement in the project. So next, please. I think I wanted to start with a bunch of trivia. Kathleen, if you could move ahead one slide, because I don't see. Yeah, right. Okay, thank you. So just to set the scene, we have a logo. The colorful ovals that you can see there are supposed to be grapes. It's a bit brutal, but but in fact, Veraison or Veraison, in fact, is a term used in winemaking. It's the onset of the ripening of the grapes. So the definition of Veraison is in fact change of color of the berries. And that's the point in time where the grapes can be many different colors. So this is, supposed in our minds to be the visual metaphor of the so fuzzy nature of trust, which can be green, right, all good, or red, or and anything in between. those two colors. So that's the idea, the concept that the logo represents. There is some debate about the pronunciation, and so you have option. The original way is the French way, and so is Veraison. But if you're not at ease with the guttural R, Veraison or Veraison are the most popular picks in the English-speaking world. Please do not spell it like the North American wireless network provider, Veraison. But anyway, it's a backronym for verification of attestation, and it's an adopted project in the Confidential Computing Consortium. It was incubated in ARM in the group we were at that point in time, but then we decided to donate it to the Linux Foundation under the CCC umbrella. Which gives us, more visibility, some more resources, and helps us integrate with the rest of the ecosystem more, easily. Next, please. Some useful pointers that I will not, go through. I just, bunch of links. You can click on them once the slides are shared. Next, please. What we provide, the goal, the aim here is to provide an open platform, and open in terms of open source, open governance with good licensing model that allows you to experiment with the RATS architecture and the emerging standards there. And conceptually, you can see two kinds of deliverables in the project. One is standalone components. So you have libraries that implement specific data formats, specific APIs, and emulators for roles, for RATS roles. And aside from that, you have a complete extensible attestation verifier, which you can use to play with the ideas, or you can even, if you're bold enough, you can put in production like Oracle Cloud did. So, next, please. So here's the usual RATS architecture, and the next slide should present the way what we actually instantiate in the Veraison stack. And so we have a bunch of emulators for the roles. We have a bunch of protocols that we have implemented in packages, and that's the current map of the deliverable. Very high level, but I think is pretty. Is pretty good in terms of it matches the reality we have at the moment. By the way, here I'm talking only about IETF RATS standards, because we also implement some TCG specific stuff, but I've not listed it here because I wanted this to be a RATS targeted presentation. Next, please. So the next is, I want to give you an atlas of all the packages that we have, broken down by conceptual messages, starting from endorsement and reference values. So this is the standards that we implement: Quorum, Suite, and Cost Suite, COTS, and COSERV. And as you can see, Golang ticks all the boxes, and these are the names of the actual packages that implement those. Rust is a bit behind. We have just gotten this Quorum RS from AMD, but that only implements, it implements Quorum and Cost Suite, whereas COTS and COSERV are not yet there, although COSERV might come very, very soon. Next one, please.
We have a gentleman in the queue.
Oh, sorry.
I think you answered my question, actually. I was going to say if there was plans to do the last two there in Rust or not, but I think you said yet. So I think that answers my question. Thanks.
Cheers, Sean. Evidence. Yes, we have EAT-based claims. It's a bit behind, but it's got what we needed for our purposes. There's certainly room for improvement there. But we don't have a Rust implementation. We only have EAT, and then we implement a couple of EAT profiles, the CCA and PSA profiles in Golang, CCA token also in Rust. As I said before, we also support a few formats coming from TCG, DICE, Cohev, and partially TPM. Next, please. That should be your attestation results, if I remember correctly. Yes, this is attestation results. We only have our 4C EAR, not surprisingly. And that has, ticks all the boxes and plus, because we also have Python and C implementation for this. And this is not surprising because this is probably the piece of the standard that is more popular these days in the open source world, and is being adopted by the Confidential Containers project as well as Keylime. So good. Next one, please. A bunch of other miscellaneous things that I couldn't categorize into the conceptual messages blocks, but they're very important. One is the foundation, right? So the crypto foundation, the GoCozy package that provides Cozy sign one, counter signatures, claims in headers. I think we have Mac at least in a branch. And something else coming from Microsoft, which I don't remember yet. If Hank is on the call, he might remember something Ash.
I think Thomas, you mean for the skid they have the nil payload stuff you're referring to here, or
No, the other, the Ash.
the Cozy hash something.
Was it hash signatures? Hash signatures? I don't remember. So I'm sorry, but there's another bit, right? So it's not just pure Cozy. And CMW, of course. We have a reference implementation for draft 15. I think I had it. I have it completely synchronized a couple of weeks ago, 3 weeks ago. And there's a Rust implementation from Jonas of the CMW thing that is in the works and is probably going to drop in the next couple of weeks. Next, please. Right, APIs. So this, this is a bit of a very specific thingy. We took inspiration from the reference interaction document to model the appraisal API. So the challenge response is based on the RIM document, but the rest is just simple, REST stuff. This can serve, say, as a point in the RATS API space that Michael is trying to map, but is, as I said, is pretty bespoke stuff, and we might want to discuss whether this needs to be promoted to a different level or it needs to stay there in just the Verizon world. All the client-side API are collected under the Verizon API client umbrella. And the Golang implementation is the one that has all the bits for appraisal, for reference values and endorsement provisioning, as well as the manipulation of the policy. So you can be the verifier owner using the API client in Go. Whereas the Rust implementation only has the challenge response bit for appraisal. Next, please. Then we wanted to talk about the emulators. So these are mostly command line tools, with the exception of a system daemon, that use Verizon packages mentioned above to build more complex functionality. So on the attester side, you can synthesize evidence and do the challenge response with a verifier in passport mode using EVCLI. With 2 subcommands, create and verify as a tester. And there is a daemon that we are developing with Oracle and Google that does the composite test evidence collection in a pluggable way. So we have basically attester backends that a lead attester will pull for and repackage using CMW. This is also an experimental work in defining the API for the collection interface. It's a big project, and it's not really an emulator. Is the real thing. When it's going to be complete, it's going to be the real thing. So I don't think this really falls into this category, but I wanted to I wanted to highlight that we have that, and it's important to show that. Next, please. Oh, Kathleen, please.
Yes, we have Usama. Do you want to take the questions now or wait?
Oh, whatever.
Okay, great. Usama?
Yeah, so Thomas, just to be clear on the challenge response with verifier, are you saying that so you do not provide any specific protocol for the communication between the entities? So the protocol is not specifically provided. Is this correct?
No. The challenge response is the protocol, and the API implements the challenge response.
But that's not a protocol, right? So that's just sending over the challenge and getting a response. What is the protocol like? How does it explicitly send over the challenge?
Using HTTPS. It's a REST API that uses HTTPS as a transport and models the protocol objects as JSON thingies.
Okay, right. Thanks.
Cheers. Okay, next, please. On the verifier side, yes, you can do evidence appraisal, well, partial appraisal. You can do signature checks and syntactic checks over the claim set using the CLI check. You can synthesize attestation results using ArcCreate, and you can verify the ref values and endorsements that come from the supply chain with a signature over them using Cochlear Quorum Verify. Next, please. On the relying party, you can do challenge response with verifier in background check mode using VCLI verify as relying party, and you can check the attestation results using Arc Verify. Next, please. The last one should be the verifier owner. Kathleen, could you please move on one slide? Yes, thank you very much. So you can impersonate the verifier owner using Cochlear. That allows you to basically manipulate the policy database, create policy, read policy, update policy, delete policies against the Verizon service. Okay, and this completes the emulators. Next, please. So the other bit, as I said before, is this complete verifier, which we call Verizon services. Next, please. The architecture is like this. We have a bunch of front ends that implement the server side of the APIs that I was mentioning before, the API client, the API server bit of the API client. And so we have 3 of them, plus one that is in the works, is in the co-server branch. It's fully functional, but is not yet merged. And they all talked through a gRPC channels, mutually authenticated gRPC channels to the core Verizon engine, which is called VTIS, another winemaking metaphor, but is an acronym for Verizon Trusted Services. Here's that encapsulates basically the attestation scheme agnostic functionality, right, in terms of appraisal, and then uses an interface to abstract the interaction with a bunch of plugins that have the attestation scheme specific bits, right? So if you have to verify each evidence, you go and talk to the specific plugin that understand that specific format. If you have to do DICE, you go to the DICE plugin through this endless interface, which is a very, very clear separation interface. And of course, there's a bunch of stores that are attached to the Verizon Trusted Services that basically collect all the reference values, endorsement, trust anchors, and policies that are needed for appraisal, to conduct a successful appraisal. Next, please.
Before we move on,
yes.
Gary has a question.
Please, Gary.
Yeah. Hey, Thomas. Yeah. So the way you pictured it here, the ECCA and EPSA and DICE are distinct. What if you had an implementation where you were using, for instance, a CCA token but you're using DICE to derive the attestation keys? Does your plugin architecture deal with that, or would you need to define a completely new profile in order to make that work?
So, if I understand correctly, Gary, you're asking whether we can combine different plugins in a composite attester verification.
Exactly, yes.
Okay, yes. Okay, no, we don't at the moment, but we are discussing exactly this thing, and we have been discussing this exact thing in the last few meetings, and we want to have that kind of functionality in order to simplify the architecture, simplify also the construction of the plugins. At this point in time, basically, at this point in time, we force the plugin writer to reuse library code, right, and compose the library code into a coherent piece. And this is not particularly good. We've seen how, for example, Oracle Cloud was trying to put together a composite attester verifier for the AMD plus VTPM stuff, and it was not trivial, right? The complexity of the plugin becomes quite interesting. So we are moving the architecture to a different pattern where basically the VTs is going to be able to understand the composition and dispatch to individual plugins the specific logic, and then put together the results.
Okay, thank you.
Yes. Okay, next, please. So this box is there. I have also some concrete deployments. We are giving you a bunch of pre-made deployments environments. One is Docker-based, which is, I would say, the most typical and most stable at this point in time, because it's also exercised by the integration tests, so it has to be, it has to work all the time. We also have an AWS deployment with all the stuff. We have tested it with our accounts. It works, it scales, and so on and so forth. But we'd be very happy if someone else would take a look and confirm that the machinery is good, because it's very complex, of course, and it relies on a bunch of things that might be assumptions on our side that are not necessarily true for other AWS consumers. We also have RPM and Debian-based deployments, in the sense that we package we build and package all the components into our RPMs and Debian, and this has been used. For example, it can be used in RPM-based and Debian-based systems. It has been used in Oracle Cloud for their deployments, and the last thing we have is a native deployment, where basically you can deploy on your laptop, either Linux or Mac OS, or better said, as a systemd system or a launchd based system. But yeah, so it's not just the thing, is also the whole assembly put together and packaged in a way that you can consume off the shelf. Next, I think is the last one. Yes, so a couple of takeaways. We wanted to target two kinds of people here with this implementation. One is the technologies that want to play with Rust-based solutions. So please take a look. You might find what you need, and if you don't find exactly what you need, you might find a base on which you can build what you have. And if you don't find that, you can provide your bits and bobs to the project, and we would be very grateful to you. And the other target for us is the student that is looking to explore the Rust architecture and standards, or hands-on, right? Learning hands-on, and this we are very, very happy to take you and guide you through. And by the way, this is very important. We also have a mentorship program that is sponsored by the Linux Foundation, and therefore, you could have a stipend out of the activity that you do. It's not just work that slave work. Is work that is paid. We are a pretty small but cozy community and very welcoming. So please join us. Go back to slide 2. I think I have left the links to the various bits and bobs, in particular the weekly meeting that happens on Tuesday. So join us and enjoy. Slide 3, sorry. Sorry, Kathleen.
Oh, slide 3. Okay. Yeah. Thank you very much. I personally think that was a very helpful overview, and it was much appreciated. Any questions for Thomas before we move on to next up was Lawrence Lundblade? Okay, great. Then I'll swap decks.
Thank you very much.
Thank you. All right, now we'll go over the EAT stack with Lawrence. Thank you.
Hello, can you hear me okay?
Yes, thank you.
Okay. All right, so this is a stack implementing EAT programmed in C. Next slide, please. So the stack is 4 packages, or 4 GitHub repositories. So there's a CBOR encoder at the bottom of the stack, and that's independently released and fairly widely used. On top of that is tcozy, an implementation of COSE signing and also encryption. I'll get into that in a little bit. That works using either OpenSSL or embed TLS crypto. On top of that is a library that implements CWT and EAT. And then on top of that is a command line tool that implements CWT, EAT, UCCS, and a little bit of JWT. These are all implemented in C. There's very minimal library dependency. The only really major dependencies these have are the crypto packages. I think QCBOR's only dependency is the math library. You can eliminate that. So like really near zero dependency. So this makes it really suitable for constrained environments and very embedded environments. The code sizes are all small, and I track code size and I spend time making sure the code sizes is small. There's no memory allocation in any of it, so it's all stack based. So you have full control over the memory use. I'm very much aiming for commercial quality, so you could just take the stuff and put it in a commercial product. That applies to QCBOR and tcozy. So there's good test coverage, there's good documentation, there's maintained releases, and like a security hole reporting procedure, and all of that sort of thing you'd expect out of a commercial package. So I'm fairly conservative about releases on these things and the quality of contributions to keep the commercial quality there. Next slide. So QCBOR v1 is out there and it's been highly stable for many years. It supports just about everything in RFC 8949. The goal in QCBOR is to implement everything in RFC 8949. It's sort of modular. There's some ifdests where you can turn features off if you want small code size. So that's how I manage to keep the code size down and still implement everything. QCBOR v2 is out there in an alpha state. Completing that is somewhat dependent on the CBOR working group completing the determinization and serialization work that's related to the CDE draft, because that's a major addition in QCBOR v2 is handling the serialization variation. Another big thing in QCBOR v2 is better handling of CBOR tags. It has the better serialization, a better big number support, supports dCBOR, and it's backwards compatible with QCBOR v1. This will, it'll probably be a while before this becomes, commercial quality, but it's still pretty solid, and it's alpha release because the API could change. Next slide, please. tcozy v1 is also highly stable for many years, a very, straightforward, solid implementation of COSE signing. It's just the single signer in tcozy v1. TCOSE v2 is quite a large jump in size and complexity because it supports encryption, multiple recipients, multiple signers. It's still an alpha release because there's just quite a lot of work to do to get it to be complete and commercial quality. It is backwards compatible with TCOSE v1. I think there's a backwards compatibility mode, but there was such a change that there's a lot there. Hank?
Yeah, hi, this is Hank. Can you hear me?
Yes.
Ah, wonderful. This is a mobile device and I'm in a vehicle, so I was worrying. First of all, thank you for TCOSE, great inspiration for years. Thank you for adding the version 2 with all the features. We have this, initially, like 2 years ago, we had this optimistic, euphoric idea to glue all the COSI together and make unit tests. We have at least for your COSI version 1, I think we have a complementary Go COSI library. And maybe it's a good idea to do some interoperability checks between them, because that was our plan a long time ago, and we kind of halted 2 years ago. So maybe now, maybe IETF 123 is a time to do some interop planning at least, and start to glue all the COSI together and see if which library features which support and then make an interoperability matrix as such. Does it sound like something you would be interested in?
Yeah, Thomas and I think maybe you too. That was the thing we started a while ago, and there's a GitHub repository for some test cases and.
Exactly. Yeah.
Yeah.
So we want to rekindle that again, maybe.
Yeah, I mean I definitely want to work on it. I just been working on other things lately, but that's certainly in the long run, yes.
Okay, it's a tentative yes. I will go with that and tease you more in the future. Thank you.
Yeah, it's just a matter of time.
Got it. I feel you. But thank you.
If setting dates helps, I can work with whoever's interested, and Ned and I can help with planning, or I can help. I don't want to necessarily volunteer Ned's time on that, but I can certainly help. I think it's worthwhile.
Thank you, Josephine. That when the time comes, we will be at your doorstep. Thank you.
Then the last thing I'll say about TCOSE is there is a partial implementation of COSE HPKE in a branch in the GitHub repository. The current plan was not to make it part of v2 because it's just a lot of work to get it to commercial quality, and that would delay the v2 release. But there's definitely been some work done there, and a plan to eventually support HPKE. I mean, that's actually a full implementation of HPKE in C. It's derived from something, but it's a fairly substantial amount of work to pull that off. So, next slide. Then CToken and Xclaim, both of these are, I haven't worked on them much for a while. They're alpha release quality. There was a predecessor, or is a predecessor of CToken that was part of the ARM software stack in TFM. So that was commercialized by ARM. CToken supports EAT and UCCS. No, not UCCS. Not UCCS. Yeah, I think it does support UCCS. It should support CMW. That would be a nice thing to add to CToken. But there's a lot of work to do there. And same with Xclaim, lots of work to do. I was kind of excited about getting Xclaim together, because once all this stuff gets glued together and works nicely, you'll be able to encrypt and decrypt and sign and verify tokens with the command line. And CToken supports CWT as well as has E. So it's a general implementation of you know, of a CWT for whatever use case you want to use it for. Okay, next slide. And there's the links for all of them. As you can see, for QCBOR and TCOSE, there are links to the formal releases and to the master, the V1 tree, and also to the dev tree. The dev tree is where the V2 implementations are. Also, the Doxygen format documents are published at a website there, so you don't have to read the headers. You can just read it from a website if that's easier for you. And then CTOKEN and Exclaim are not formally released yet, so just one, V2. So, you know, contributions are appreciated. Lots of people have contributed to all of these over the years. I mean, I'm fairly conservative in picking up things because of the goal to maintain commercial quality, but really appreciate any work here. All right, thank you. That's it.
Thank you very much, Lawrence. Any final questions for Lawrence before we switch and Usama will present next? Okay, so this is, I think this is all very helpful because it's informing people of what's available. And so let's see. So now he has some work on attested TLS and libraries. So I'll hand it over.
Yeah, thank you very much, Kathleen. Yeah, I talked about attested TLS in the last interim, and this is a continuation of that, kind of summarizing what we have learned over the years, what are the gaps, and what's the way forward. Next slide, please. Okay, so I have two basic topics, one to talk about the gaps, and then some continued discussion from the last interim where we had about the CSP and so on. So I will come to that. Next slide, please. Okay, so this is the kind of visualization of how we visualize all possible solutions in the space. The green representing the remote attestation part, what point in time temporally we sign the claims, and signing of the claims always happens at the attester site. So it's a one-directional view of the attester, and at what point in time relative to the TLS handshake I'm doing the signatures. So this is exactly showing three different options, and we can do it before, after, or in between, which is namely pre-handshake, intra-handshake, and post-handshake. And next slide, please. So we have solutions for each of those pre, intra, and post in the industry, which are used for confidential computing, specifically for pre-handshake Intel's RATLS protocol, the first column. The second column is describing the TLS attest internet draft, which was a proposed draft in the TLS working group. And the third one is the SCONE solution, which is closed source solution, unfortunately. And I believe that for confidential computing, it doesn't work without open source. Like if I don't have the reference values, where do I actually get those? What components are in the software itself? So we cannot really check that. So it's not possible candidate, let's say, for standardization. And also there are no specifications available. We don't know what exactly is being done here. We explored a lot about in detail all the papers and relevant works that were, and all the specifications and details discussions from the SCONE developers. But still it has some problems that I will describe in the later slides. And as you see, it has no formal specification and not even informal specifications. And for the draft standardization, specifically at the TLS working group, there is a formal methods requirement, as I have already talked about before. So next slide, please. Okay, so now I will talk about each of those solutions, pre, intra, and post, and describe the limitations, or let's say the gaps between each of those solutions that exist. And specifically, just as a recap, so the signatures happen here before the TLS handshake protocol starts. So you already have an evidence even before starting that handshake, and obviously it can be replayed across any number of sessions that the party has, or that specific entity, let's say the attester has. So per session evidence freshness is not provided. And secondly, there is a critical thing, which is runtime integrity, which means that if there are changes at the runtime when the attester is actually executing, these claims are actually not available at the point in time this signature has been done, which is the green arrow is showing the point in time. And at that point in time, we have no runtime integrity measurements. That means it's basically going to ignore all this runtime behavior of the attester. And that's why it's a solution that's not recommended for standardization. Specifically in the industry, there are two specific solutions. I already mentioned Intel's RTLS. There is an internet draft CSR attestation. But the problem with that specific draft solution is that it introduces a reliance on the certification authority. Namely, it's now the certification authority which will actually provide you the guarantee and check that whether the evidence has been, let's say, is good or not. So you rely on that specific certification authority to not only, not only give you the guarantees about the entity identity, but also about the evidence, meaning that your whole trust is basically now shifted to the certification authority, which is not good, because now if that breaks or something goes wrong, then all of your trust is broken. And the chain I talked about in the last interim, like the two chains, that kind of thing cannot be done in this kind of solution. So in the last interim, I have a reference to these slides below. So we already talked about the diversion attacks, which can happen when an entity wants to connect to some specific data center, and that identity is not provided in these solutions, which are only generating the key ephemerally. And that's why we cannot have the guarantee that which data center I'm communicating with. So diversion to different data center as well as within the data center are possible, as we discussed last time. Next slide, please. Okay, so for intra-handshake attestation, there are also general limitations, like the runtime integrity. Even if we do at the point in time the handshake is running, we still don't have these runtime measurements. And so it has the same problem that pre-handshake attestation actually had, meaning that the runtime integrity cannot be provided. Any solution of intra-handshake cannot provide this kind of guarantees. And it also requires invasive changes to the TLS protocol, and potentially as deep as key schedule, which is one of the new exporter required for the solutions that we proposed as well. And it suffers from the same problems from a GAP's perspective. The internet draft, specifically to this internet draft, there is diversion attacks possible, as we discussed last time. The idea is that it's not a general limitation of intra-handshake, rather of that specific proposal for that internet draft. It means that it could be solved, like we proposed some solutions in the TLS working group with which it could be solved. So it's not a general limitation, it's the limitation of that specific internet draft. Next slide, please. Okay, so then we have the last option, which is the post-handshake. The TLS handshake has completed. We have exporters that we can utilize to export it over to the attestation, which has a couple of general limitations also. But it's important to emphasize that when we are adding something to TLS, of course, there will be some changes required. And it depends now on which layer you want to change. Like for example, attested, this CSR attestation is actually going to change the CA. It's some changes still required. And in intra-handshake, you change the TLS protocol. And in this case, you need to change the application layer. And the point here is that you actually need to change something. So what exactly do we change? So that's, in this case, is the application layer. And there is a small latency impact, and which cannot be avoided, because at the top of the TLS protocol, you need to have one round of sending over the request and then getting back the evidence. And this is inherent to the solution. However, I would like to emphasize that it's still better than rerunning the whole TLS protocol from the start, going through the 1.5 round trips. Just doing let's say a single round trip is still better than having rerunning the whole protocol from the scratch. So it's still better than using pre and intra. Hank, please.
Hi, yeah, this is Hank. So you're sending over evidence here, right, at the TLS post? Okay. So I want to say runtime user space evidence from a TPM is relatively small. It's a quote. That's nice. But you need also to send over the event log, which can be megabytes, and typically goes into very long numbers of megabytes, like 500 or something, if you have a big system. So so how are you dealing with that?
Okay, so I think it might be possible to send over a hash for that and send over the log separately.
You need yeah, exactly. The logs somehow have to be there for the quote. So maybe it's an async operation. So you have the logs at hand and then do the TLS and then the final quote from the TPM, which would work. But the log replay has to happen at the verifier. So if you're doing the evidence over the TLS session, then there could be a volume issue if you have complex systems, right?
So I'm not sure about the volume yet, but what we have explored is that the replay would not be possible because every evidence request that you send has exporter.
No. Replay is a good thing here. So log replay means that you result in all measurements that would then be the TPM quote hash. And in order to get that hash on the verifier side, you have to replay all measurements. So replay in this is not a replay attack, or it's not a protocol problem. It's a wanted feature for remote attestation.
Okay, so then I'm not aware of this. I will then get back to you on the list about this.
Okay, thanks.
Okay, so the solution that we have explored specifically, so these were the two generic limitations. I want to emphasize again that it's small changes comparatively to the other two solutions, and the benefit that we get is we do not need to, in this specific case, the runtime integrity problem is solved. At any point in time after that, whatever claims I want and at whatever time I want, I can have the complete picture of the status. So Lawrence.
Yeah, I wondered if you could tell us or tell me a little bit more about the issue with the runtime integrity, the timing of it, and why you think that's so important. I mean, it seems like we're only talking about milliseconds here between all of those things. And usually runtime integrity, I don't know, I always thought you ran it more like once an hour or something.
So it could be, so the first point is the runtime integrity claims become only available once the VM. So first things first, so we are talking about the virtual machines, the complete virtual machines compared to the enclaves, the small enclaves. Let's say we are not talking about the SGX enclaves. Now industry is completely shifting towards the VM based trusted execution environments. And in this case, we are talking about a complete VM, which means that it has started executing, and the time at which it will build that TLS connection, it will not have any information about what exactly is going to run, what will be loaded and unloaded at the runtime. So when I say runtime, that means that what will be executed inside that specific VM, and what can be offloaded or unloaded. So many things can change at that specific runtime. And if I keep continuing like using pre and intra, I will have no information whatsoever on what is executing within that VM, the whole VM. Does that clarify your point?
One more question. So you're saying that the configuration of the VM changes over the course of the...
as well as the configurations, as well as the components within that VM. Like some things could be loaded in the VM at the runtime.
Yeah. Okay. So you're saying that changes over the, sort of during or before, during, and after the TLS handshake.
Yeah.
Okay. Understood. Thanks.
And it could be at any frequency, like it could be 1 hour, the timing that you mentioned, like 1 hour, 1 second, or whatever, like 1 day or 1 month or whatever. So the benefit of this post handshake solution is I can send over a request at any point in time I want. So that's something that is For both of the previous solutions, I need to rebuild a connection at best. And that's what we can avoid just by one round trip rather than doing a 1.5 round trip. So
you could do attestations after the TLS handshake several times. Yeah.
Right. Yeah. As many times as you want. Just send over any request, and with that you will have, with that nonce, you will have a new evidence, and then you send it over. The appraisal happens. So at any point in time, with all the claims of the current status of the VM, you can have that runtime integrity.
So it's not really bound to TLS anymore. It's just like you got a secure channel and you're doing an integrity check periodically.
Right. It's on top of TLS, if that's what you mean. Like it's running on top of TLS.
Yeah. Okay. All right. Thank you.
Yeah, it's basically specifically about the solution that we have written at the bottom of the slide that's using RFC 9261. Giri.
Yeah, just to be clear, when we're talking about runtime integrity checking, we're not talking in this case, at least the way I'm understanding you, Osama, about, like, for instance, some process running within the VM to assess the health of the kernel. I think we're talking about, like, for instance, changes in the TCB from launch to the current state, in which case that should always be reflected in the attestation. So there's not any special thing that needs to be done within the VM itself when it's retrieving the attestation. You just the attestation just if the TCB is extended as part of the during runtime, then the attestation will reflect that. So it's not. So I don't think you're really doing anything special from that to track runtime changes, because you're only tracking runtime changes to the TCB, right? You're not tracking runtime changes to anything else with the VM. Is that correct?
So my understanding is that so TCP itself is of course included. I mean, you have the platform evidence, and then on top you have the attested evidence, and any of those. Now the question is TCP from the perspective of the workload is that platform, and TCP from the perspective of the user is basically both of those. Like any changes in the platform, any changes in the TM from user perspective, it doesn't matter, right? So change is a change. If anything changes from the expected one, for me as a user, it's a change. And post handshake, like pre handshake, the point I want to make is that the platform evidence changes could be detected by pre and intra, but these changes in the VM could not be detected by the pre and intra solutions. It's only the post handshake solution which can provide you guarantees about what's happening in the VM actually. And that's important distinction, because the other two, independent of whatever protocol you use, you cannot actually provide these kind of guarantees there.
Okay, so let's assume that the handshake starts and an attestation is sent by, attestation is created by the attester.
Yeah.
Then for some weird reason, before the handshake completes, the attester realizes that the TCP has changed, it's extended. Is that worth even tracking in the context of handshake, or is that something that is the attester expected to abort the handshake at that point?
Just to be on the same page, so are you talking about intra handshake solution?
Yeah, let's start with intra handshake. Yes.
Okay, so if you are talking about intra handshake solution, so you generated an evidence within the handshake. And Kathleen, can you go to the last slide, one slide back, please? This one, sorry. So if what you are saying is basically I was running the TLS handshake, I as an attester generated that evidence. Yeah. And now you're saying that before I sent over the evidence, or before the handshake actually completed, the dots on the right, you are saying that the status of the evidence itself, of the attester actually itself has now changed, right?
Yes.
So that would exactly be the case that we would eliminate. That's not possible to solve, because it's time of check to time of use that you cannot actually solve that. So I think it would be out of scope for at least I can't think of a solution for this.
No, that's fine. So as long as the working assumption is that for those weird cases where you have evidence changes within the context of the handshake itself, you just aren't addressing it. That's fine. Sure. You just say it's minimal probability that'll occur. Okay, thanks.
Okay, so I'm chiming in to do a time check because I would like to make sure we at least leave 3 minutes to do any summary and then have other people speak up in terms of other efforts, and they can also share them to the mailing list. Hannes has shared a number of other efforts in the chat. So go ahead and just be cognizant of time. We have 6 minutes to the top of the hour.
So I will then maybe skip the discussion part. We can do it maybe in Madrid. So if you could please go to the slide on the, yeah, I will skip this one. I think I will just, next one, please. Next one. So I will just invite people to the BOF with the conclusion that basically we have a preliminary proof with an abstracted model where we have the guarantees that it's the post-handshake solution that I showed actually fulfills all the requirements that we have. It guarantees that the TLS properties are satisfied. It guarantees that the freshness is confirmed via RFC 9261. And it preserves both properties from rats from the TLS, and then the composition goals that we had are also satisfied via that solution. And I would very much like to, on behalf of all the proponents, I would very much like to invite all of you to the BOF. And yeah, thank you very much. Any questions?
All right, any questions for Osama? And then we'll switch to an open mic and hopefully discussion of additional efforts, or if there should be a follow-on discussion for hackathon work. And I encourage anyone else who didn't have time to present but has been involved with other libraries to share those to the mailing list so that there's more full awareness. Okay, so I'll switch off his slides now and then just go to open mic on libraries and other work. Okay, I personally thought this was a very helpful session. Did others find this to be useful? Is this something that should be repeated? And not too soon, obviously, because they were just reported out, but when there is significant status. Maybe I'll, yep, Thomas.
Hey, Kathleen. So just a thought. Yeah. What I was presenting was basically 4 years worth of work, right? So that's why there's a lot of stuff. But effectively, so we have incremental drops of functionality here and there in this or that package. Is there a way that we can sort of socialize this with the Rust working group in a more structured way than just maybe, the email that I might decide to compile if I feel it, right? So a way to actually report the status of all the implementation that are RATS related somehow in a way that is dynamic, right? People can actually see the whole picture and see where each of the individual pieces stand and et cetera.
So that's an interesting way to phrase it. I appreciate that. I think right now we can use the mailing list, and for the data tracker, I believe there's a link for implementations. So that is one place. The other is the Shepherd's report includes an entry. So anytime we are working towards publishing a draft and it's in the last phases of publication, we should be entering all the applicable efforts, because it does matter to have multiple implementations for standards track documents before they get published. And it's really helpful for the community to be aware. And then even when there's things like interoperability testing that was suggested, that's also very helpful for the community to be aware of. But you talked about the interrelationship, and perhaps if we get some volunteers, maybe that would be helpful to draw up in maybe a wiki where we could maintain what those relationships are. And perhaps that's a step beyond what's been proposed, right? So that you could show the relationship between the libraries and the documents. And how does that sound?
Sounds good. I will think about it. The thing is that we need to keep those documents up to date because they tend to become stale. That's why I was sort of hinting at the structured way, right? So a way that is not necessarily a process, but some sort of tooling around these all efforts that allows us to coordinate and interop matrix, whatever, you know. Well, I'll think about it.
Yes, and I'm happy to assist. So, you know, if I can help from an organization standpoint, I'm very happy to do that.
Yeah, let's talk in Madrid, maybe at the hackathon if you're around. We can have a chat.
I'll be in Madrid, yes.
Cool.
Thank you. And thank you for your presentation. Hank.
Yes, really quick because we're approaching the top of the hour. So there is this thing called a software bill of material, which is a dependency document for libraries. Maybe we can use those. I mean, don't throw stones at me yet, but maybe it's useful to do that. Just as a food for thought for next meeting.
So I think that's a great idea. The one thing with SBOMs is that it was removed from the executive order. So for that work to go forward, I think standard supporting it is its best bet. I know a significant amount of effort went in by a very large number of people. So that removal, just in terms of requirements, might hurt the effort somewhat, but standards could really pick up that slack.
Yeah, make a difference there. Exactly. Wonderful. We will try to do that. Thank you.
Thank you. Yogesh.
Yeah, I was just wanted to say that SBOM may be required for removed from the executive order, but EU CRA does require that. So just don't ignore that, please.
Great. That's good to know that that's requirement
But
exists.
it's optional in the CRA. It's not mandatory. Yogesh.
Okay.
The composition, okay, we can go in circles here, but the composition and vulnerability assessment does require that, because vulnerability
That's true. Implicitly, yeah.
implicitly
but it
it is
doesn't say
required.
that you have to share it with customers. So
Yeah.
it doesn't require an interoperability sort of interoperable mechanism in that sense.
That's true. Yeah. But
of course, it would make everything simpler.
Yeah.
Okay, wonderful. I greatly appreciate everybody's contribution. And I apologize. I thought the agenda was posted because I had shared it with the participants who were presenting. And so that was my fault. And we'll try to do more interims after the July session. And you can start sending in your requests for presentation for July as well. Thank you. This was really great.
Thanks a lot.
Thanks a lot.